Let's talk about factoring the sum and difference of two cubes. Now we've talked about already the factoring of the difference of two squares, but another pattern that occurs occasionally is this thing called the sum or difference of two cubes. And the pattern is this. I have it right here for you. The difference of two cubes, so x to the third minus y to the third, so difference, perfect cube, equals x minus y, so the cube root of this, times x squared plus xy plus y squared. And I know that looks like a lot and somewhat challenging to remember, and it is at first, but the more you do it, the easier it becomes. And then the sum of two cubes is really similar. If you take a look, you'll see, now this is different than, different to two squares, it was only minus. But with cubes, we can have plus as well. And so in this one, again, you notice it's x and y, so the cube roots, it's x squared, xy, and y squared. The only thing different are the signs. And one way that you can remember the signs is the word SOAP, meaning this first sign is S. Okay, S stands for the same, so this sign is the same as this. This middle sign is O. It's always the opposite of this, so this is plus, this is minus. If it was minus, it's plus. And the last one is AP, always positive. So this one's always plus. So SOAP is one way that you can remember at least the signs. Now the rest of it, you're just going to have to spend a little bit of time and just kind of put a little memorization into that. And we're not going to go through it right now, but if you were to distribute this x minus y into this, or the x plus y into this, okay, it would actually simplify all the way back down to both of these. Okay, so let's do an example. So here we have x to the third minus 27. And so what I think is helpful is to start out by just listing what the cube roots of both these terms are. So the cube root of x to the third is just x. The cube root of 27 is 3. And so to factor it, okay, it's minus, so I'm going to do the signs first. So it's same, opposite, always positive. And so the first number is the square root, so that's x. The second one is the cube root. This one is the term squared, this term squared. The last one is this one squared. And then the middle are these two put together. So it factors, if I simplify it just a little bit more, x squared plus 3x plus 9. And one thing that that over time you'll notice, but as I look at this, this is always going to be completely factored. So in other words, this part especially won't ever factor anymore, okay, when you're doing these simple difference of two cubes. So doesn't mean that this one won't. Normally it doesn't, but this one doesn't factor anymore. So let's do another one. Well, first let me change this little typo here. Sorry, this should be y to the third right there. So I'm going to list my cube roots first. So the cube root of 8y to the third is 2y. The cube root of z to the third is z. Okay, so I'm going to set everything up. So it's plus this time, so it's same, opposite, always positive. First numbers are the cube roots, so we have 2y and we have z. These terms here are the squares, so it's going to be 2y squared, the whole thing squared. This one will be z squared. And the middle are these multiplied together, so it's 2yz. So to simplify, I get 2y plus z. This 2y squared is 4y squared minus 2yz plus z squared. And there you go. So again, as you do more and more of these, actually not that bad, okay? Not that difficult to go about figuring out, you know, how all these things work. Okay, so let's take a look at the next one. It says 6x to the third minus 64y to the third. Okay, so let's first start talking about, all right, well, what are the cube roots? Well, right here you notice that 6 x to the third is not a perfect cube. So right there, this doesn't factor into this pattern. Okay, so that's something you have to kind of pay attention to, that it doesn't, even though it kind of looks like it, you got to pay attention. This is not a perfect cube. The only thing you really could do to this is, I noticed that you have a 6 and a 64, so I actually could factor out a 2, and I get 3x to the third minus 32y to the third. And that's it. Okay, not super exciting. So the whole point of this one is make sure you pay attention. 2 plus 2 plus 2 is 6, but again, the cube root has to be something that's multiplied by itself 3 times. Okay, last one. Let's talk about this last one down here. It says 8n to the 6th plus 125m to the third. So cube roots. So the cube root of 8n to the 6th is 2n squared. And the cube root of 125m to the third is 5m. Okay, so now if you don't believe me on this one here, that 2n squared is the cube root of that, think about that. If you multiply 2n squared times 2n squared times 2n squared, it'll come back to 8n to the 6th. So it's a plus. So in terms of my signs, it's going to be same, opposite, always positive. The first terms are the cube roots, so 2n squared and 5m. The outside terms here are going to be the square, so it'll be 2n squared squared, and then 5m squared. And in the middle are these two together, so it'll be 10mn squared. So let's clean it up a little bit. So I get 2n squared plus 5m. So this 2n squared squared is going to be 4n to the 4th minus 10mn squared. And this 5m squared will be 25m squared. And there you go. That is the sum and difference of two cubes.